So students, I welcome you once again in the lecture series of indefinite integration. Indefinite integration. This is lecture number 14 in indefinite integration. Today we are going to see the new type of problems. So let's start with a type. A new type of integral. What is this type? I have one integral 1 upon a cos square x plus b sin square x plus c dx. 1 upon a cos square x plus b sin square x plus c dx, where a, b and c are real constants. They are some real numbers. So let's have few examples of this type of problem. For example, let's have few examples. 1 upon 4 cos square x plus 3 sin square x plus 7. So this is the type. Okay. I may get such a question to be integrated, and if it is so, then what type it is? It is this type. See, there are other examples also. Suppose I have 1 upon 3 cos square x plus 2 dx. So when I have 3 cos square x plus 2 dx, what I can say? I can say that this b is 0. B is 0. Now since b is 0, if value of b is 0, 0 into sin square x, so I will have no sin square x. That's why in the denominator you see in this problem, in this integral problem, you see that in the denominator there is no sin square x term. There is no sin square x term. Okay. Then you have, you can have one problem, 1 upon, say, 2 sin square x minus 1 dx. Now here I can say you don't see the cos square x term. So you can say that a was 0. A was 0. So 0 into cos square x, you get no cos square x. Then you can have 1 upon 3 cos square x minus 7 sin square x. And you notice that there is no constant term. So you can say that c is 0. What you can say? You can say c is 0. So these are different types of, these are different examples of this type of problem. So in short, what you can say is you have 1 in the numerator, and in denominator you have terms of cos square x, sin square x and constant. What you have? You have terms of cos square x, sin square x and constant. So we can start with the method. If you have this type, then what is the method to solve it? What is the method to solve it? So I write the method for this method. Step 1. Step 1 is divide numerator and denominator divide numerator and denominator by cos square x. I repeat, what we do, we divide the numerator, this is numerator, right? So we divide numerator by cos square x, and this is denominator. We divide denominator by cos square x. Okay. Now when you will divide the denominator by cos square x, in denominator you have got three terms. Okay, you have three terms. So each term will be divided by cos square x. You will split the cos square x which you have in the denominator. Okay. So divide numerator and denominator by cos square x. Then you have step 2. Step 2 is, after dividing numerator and denominator by cos square x, step 2 is write denominator in terms of tan x, completely in terms of tan x, or you can say in terms of tan x and a constant. A constant can be allowed, but nothing other than tan x and constant. So write denominator in terms of tan x and a constant. So what is permissible in denominator? In denominator, what is permissible? Tan x is permissible and a constant is permissible. What does that mean? See here, you have 4 cos square x, 3 sin square x, and 7, right? So you will divide numerator by cos square x, and you will divide this denominator by cos square x. You will divide denominator by cos square x. After that numerator will become sec square x. 1 upon cos square x is sec square x, which we will see when we will solve the problem. Right now I'm just helping you out with the method, the step which I wrote in the method. I'm just helping you out. So the numerator you will get cos sec square x, and in denominator this cos square x you will split for each term. Now after you will have split, you will make sure that whole denominator you see only tan x and constant. What do you see? You see only tan x and constant. It means in denominator you should not have any cos, you should not have any sine, you should not have anything, but what you should have? You should have only tan terms with a constant. Okay. Then step 3. Step 3 is put tan x equals to t from the denominator. Okay, in denominator you have tan x. So what you will do? You will put tan x equals to t from the denominator. Now when you put tan x as t, what do you get? You get hence you get sec square x dx equals to dt. Because you will differentiate this when you are putting tan x as t, you will, after substitution, what do? You differentiate. So you will differentiate with respect to x. You will get sec square x dx is dt. And don't forget that after you will have divided numerator and denominator by cos square x, this numerator would have turned into sec square x. It would have turned into what? Sec square x dx. So this sec square x dx would get you dt. Okay. So put tan x as t, hence sec square x dx is dt. Step 4. Step 4 is apply the type apply the type 1 upon, apply the type 1 upon quadratic, apply the type 1 upon quadratic dx. Remember students, after step 3, what you will see? You will see that the given problem has turned into a new type of problem. What problem? It has turned into 1 upon quadratic. Apply the type 1 upon quadratic dx, or or set set one results, or set one results. So you will find that after the step number 3, after the step number 3, you will notice that you have ended up with a new type of problem, or you will find that now you can apply set one results. You all know that once you reach this type, after this you can integrate, because this you have already integrated. Okay. Or also you know that if you after step 3, if you notice that you have to apply this result, you could also apply the result. So what I want to tell you is, this is the type and the method. Let's have a illustration and you will understand this much better. Let's solve a problem. So I take a question for you, and that is, let me take a question. Okay, so I write here question number 19, and 19th problem is, let I equals to 1 over cos 2x plus 3 sine square x dx. 1 over cos 2x plus 3 sine square x dx. So here, see what do? I will apply the formula for cos 2x. I know cos 2x is cos square x minus sine square x. What is cos 2x? Cos square x minus sine square x. For cos 2x, I wrote this. And here I have plus 3 sine square x. So, so I get, next step, I get 1 upon cos square x plus 2 sine square x. So what you notice, students? You notice that it is the type which we had written. It is the same type which we just saw. Numerator is 1 and the denominator you have terms of cos square x and sine square x. You have terms of cos square x and sine square x. So what is next step? You know the step. Once you notice that it is that type, you will write divide numerator and denominator by cos square x. Divide numerator and denominator by cos square x. So see what you get. You get I equals to 1 upon cos square x, 1 upon cos square x dx. And here you get cos square x plus 2 sine square x upon cos square x. Okay. So you get I equals to 1 upon cos square x is sec square x dx, and here you will split the denominator. What you will do? You will split the denominator. So cos square x upon cos square x and 2 sine square x upon cos square x. Yeah. So I get here cos square x. The numerator is sec square x and dx we already had. In the denominator, what I do? I split the denominator. This one, I separately divide these two terms by cos square x. So cos square x upon cos square x, which will get me 1. And here it is 2 sine square x upon cos square x, which will get me tan square x. So I get next step as sec square x dx. And here I get 1, cos square x cancels. So 1 plus 2 tan square x, 1 plus 2 tan square x. So the step 1 was divide numerator and denominator by cos square x, which we did. which we did, divided by numerator and denominator by cos square x. Step 2 is write the denominator in terms of tan x and a constant. That is also being done. You can check. Write the denominator. You can see, students, in the denominator now I have only tan term, I have tan x term. This is tan x the whole square. See, tan square x means tan x the whole square. So it is still what term? It is term of a, it is in terms of tan only. So tan square x is nothing but tan x the whole square. So now I notice that step 2 is also done. And I also have a constant which is permissible. What is step 3? Once you have done this, step 3 is put tan x equals to t from the denominator. Okay, so I put tan x as t here. Students, watch this. I write here put tan x equals to t. Put tan of x equals to t. Now, you know, if you put, then you will differentiate. Differentiating with respect to x, d by dx of tan x is sec square x, and d by dx of t is dt by dx. Okay, so the next step I get sec square x dx equals to dt. Okay, this is, so what would I do next? I will write for sec square x dx, I will write dt. For sec square x dx, what I will write? I will write dt. Okay. So the new integral that we will get is I equals to sec square x dx is dt divided by 1 plus 2 tan square x. What is tan x, dear students? Tan x is t. So tan square x will be t square. Okay, I hope you followed it. Tan square x I had here. I had tan square x, 2 tan square x. So this is nothing but 2 tan x the whole square. So, and tan x was t. So I get 2t square. I get 2t square. Okay, that's very good. Now check this out. What we will have next. Now I notice that this is set 1 theory working here. You remember three theories from the set 1. So I write here 1 upon, this is 1 plus 2t the whole square. I write 1 upon 1 dt. First of all, numerator dt can be written as 1 dt. Then this 1 I can write as 1 square. I can write it as 1 square plus 2t square. I can write this as root 2t the whole square. What I can do, I can write root 2t the whole square, 2t square. Okay, why did I do that? Because I wanted to write it in the form where I can apply the results. So what exactly form I want to write this in? I'm working for this form, 1 over a square plus x square dx. 1 over a square plus x square dx. I'm working for this form. And integration here is 1 over a tan inverse of x over a. So this will become, what it will become? It will become 1 upon 1 tan inverse of root 2t upon 1 variable upon constant into 1 upon root 2 plus c. So I hope you follow that why I have to multiply 1 upon root 2. I multiplied this 1 upon root 2 because where I'm applying the result at that step, I have root 2 as a coefficient. Root 2 is the coefficient of t here. So I have to divide by the coefficient. So I get I equals to 1 over root 2 tan inverse of root 2t plus c. And what is t? T is tan x. So I have I equals to 1 over root 2 tan inverse of root 2 tan x plus c. You can, this is the end of the solution. You can once again watch this to understand better. Let's take one more problem here. 18th. This is from exercise 3.2b. 18th is let I equals to 1 over 4 plus 3 cos square x dx. So as I noticed that it is the same type. In numerator I have 1, and in denominator what I have a cos square x term with a constant. Okay, I have a cos square x term with a constant. So as you notice, students, the type that we are working on, it can have a cos square x terms with a constant. Okay, then or it could have sine square x term with a constant, or it could have only cos square x sine square terms and no constant, or it may have all the three. So we are working on this. So 1 upon 4 plus 3 cos square x. I will write here, divide numerator and denominator. Divide numerator and denominator by cos square x. So I will get therefore I equals to 1 upon cos square x dx, and here I have 4 plus 3 cos square x upon cos square x. Okay, so I have therefore I equals to 1 upon cos square x is, I write this as sec square x dx, and here I will split the denominator. So when I split, I get 4 upon cos square x plus 3 cos square x divided by cos square x divided by cos square x. So what will I get in the denominator? I shall now be getting I equals to sec square x dx, and here I get 4 sec square x plus 3. So students, if you remember, the second step was you need to write the denominator in terms of tan only, in terms of tan and a constant. So here I see sec square x, which is not permissible. You know, sec square x is not permissible. What will I do? I will write sec square x in terms of tan. So can I do this? Yes, because we have an identity, and the identity is sec square x equals to 1 plus tan square x. So here I have sec square x dx, and in the denominator I have 4 times 1 plus tan square x plus 3. So this gets me I equals to sec square x dx, and I multiply this 4 inside. 4 plus 1 is 4 plus 4 tan square x plus 3. So this I get as I equals to sec square x dx and 4 tan square x plus 7. 4 tan square x plus 7. The next step is, after you see in the denominator you have got the terms of tan x only. Complete denominator is in terms of tan x. If you see something in x in the denominator, it has to be tan. That's the condition. If you see something in x in denominator, that has to be tan of x. Do we have that? Yes. So now I move to the next step. The next step is put tan x equals to t. Put tan x equals to t. So if tan x is t, students, differentiating with respect to x, I will get sec square x dx equals to dt. So what is this equal to? Sec square x dx is dt, right? So I get therefore I equals to, the numerator is dt, here I get dt, and the denominator is 4 tan square x plus 7, 4 tan square x. So 4 t square plus 7. So I get here 1 upon 2t the whole square plus root 7 square dt. 2t the whole square plus root 7 square dt, right? So what I have, 1 upon 2t the whole square plus root 7. And this is one of the result from set 1. 1 upon constant square plus variable square. So the answer will be I equals to 1 over root 7 tan inverse of 2t upon root 7 into 1 upon 2. You know why this 1 upon 2? This 1 upon 2 because I have the coefficient of t here as 2. So I have to divide by 2. So multiply 1 by 2. So the final answer is 1 upon 2 root 7 tan inverse of 2t. What is t? T is tan x. 2 tan x upon root 7 plus c. This is answer. Okay. You can see the whole thing once again here. I take another question for the practice. So let's have one more problem here. That is problem number 20. I solved question number 20. Question number 20 here is I equals to sine x over sine of 3x dx. Now this is very interesting question, students. In the first go, someone might think that what kind of question is this? How do I integrate this? But then say you have to apply sine 3 theta formula. Sine of 3 theta is 3 sine theta minus 4 sine cube theta. So sine of 3x will be, so numerator sine x I write as it is, and in the denominator I write 3 sine x minus 4 sine cube x and dx. Now what I do, I take sine x common from the denominator. So sine of x here, I take sine x common from the denominator. When I take sine x common from the denominator, I get 3 minus 4 sine square x dx. Okay, so this sine x and this sine x cancels. So I equals to 1 upon 3 minus 4 sine square x dx. 1 upon 3 minus 4 sine square x dx. Now after this, what do you know? You know the rest of the steps. I see here it's the same type of problem. What is it? The numerator is 1 and the denominator has a term of sine square and a constant. So step 1, you will divide numerator and denominator by cos square x. So here I write divide numerator and denominator by cos square x. When you do that, you get I equals to 1 over cos square x dx, and here you get 3 minus 4 sine square x over cos square x. Okay, so this will get you I equals to sec square x dx, and here I split the denominator. So 3 upon cos square x, 3 upon cos square x minus 4 sine square x upon cos square x. So I get I equals to sec square x dx, and 3 upon cos square x is 3 sec square x minus 4 tan square x, 3 upon cos square x is 3 sec square x, and here you get sine square x over cos square x, which is tan square x. So numerator is sec square x dx, always like this. In this type, after you have divided by cos square x, the numerator will always get you sec square x dx. In the denominator, what the condition was? The condition was you should have complete denominator in terms of tan. Nothing other than tan is permissible in the denominator in order to achieve the integral. So here tan square x, this is okay, this is permissible, but sec square x is not permissible. What I will do, I will write sec square x as 1 plus tan square x. I will write sec square x as 1 plus tan square x. Then this 3 outside will multiply inside the bracket, okay, and so on. After that, once you get everything in tan, you can always integrate this. You can always integrate this. So I will have here sec square x dx, I equals to, I have I equals to sec square x dx over 3 into 1 plus tan square x. This 1 plus tan square x is being written for sec square x minus 4 tan square x. I have 4 tan square x. So the next step is sec square x dx. Multiply this 3 inside. So I have 3 into 1 as 3 plus 3 tan square x minus 4 tan square x minus tan square x. Plus 3 tan square x minus 4 tan square x is minus tan square x. Okay. So now after this, I will write put tan x. Next step is put tan x equals to t. So differentiating with respect to x, we will get sec square x equals to d by dx of t. That dx I multiply here, it will become sec square x dx as dt. So this sec square x dx is dt. I get I equals to dt divided by 3 minus t square. Dt divided by 3 minus t square. So what do I get? I get I equals to 1 upon 1 dt. So 1 upon 3. 3 I will write root 3 the whole square minus t square. So this is you will have 1 upon a square minus x square dx. You check this. What kind of integral is this? It is 1 upon constant square minus variable square. 1 upon constant square minus variable square. And what is that? It is 1 upon 2a log of a plus x upon a minus x plus c. 1 upon 2a log of a plus x upon a minus x plus c. Okay, so here I will have I equals to 1 over 2a, 1 over 2a. What is a? A is root 3. So I have 1 over 2 root 3 multiplied with log of a plus x, that is root 3 plus t upon root 3a minus x, root 3 minus t plus c. And then I will substitute what t was. T was tan x. T was tan x here. You can check. So I have 1 over 2 root 3 log of root 3 plus tan x, root 3 plus tan x, divide by root 3 minus tan x plus c. This is it. You can check the whole solution once again. Let's see one more type of integration problem. Type. It's a new type of integration problem. The type is 1 upon a cos x plus b sin x plus c dx. 1 upon a cos x plus b sin x plus c dx. So here, what do you notice? You notice that numerator is 1. The denominator is a cos x plus b sin x plus c. If you compare this type with the earlier type, you notice in the earlier type what we had? we had cos square x, we had a cos square x. Check what we had. We had a cos square x plus b sine square x plus c dx. So in totality, the difference between these two types is that here we have cos square x, here we have cos x, whereas in the earlier type we had cos square x. So here we have cos x only, not cos square. Remember, it is not cos square. What we have cos x only and sin x. We don't have sin square. We had sin square and cos square in the earlier type. That's the major difference. And here I write where A, B and C are constants, where A, B and C are constants. What constants? They are real constants, real constants. That is A, B, C are real numbers. Now we go for the method. See, this method here is very much different from the method that you had in the earlier type. In the earlier type, what it was, the earlier type you said divide numerator and denominator by cos square x. You said divide numerator and denominator. You divided numerator by cos square x and denominator by cos square x in the earlier type. Now some students might think that in the earlier type we had squares here, so we divided by cos square x. Now this time we do not have squares, so we will not divide by cos square x. Instead we will divide by cos x. So that is not the case, students. Mathematics doesn't work that way, please. Okay, so please don't think that way. There is no such method here. The method is too different from what you all are thinking. So what is the method? The method, step one is put tan of x by 2 equals to t. I know you all must be thinking that how could this be the substitution, because if you remember, I had told you that when we are substituting something as t, we always check that we have that substitution from the integrand. So if this whole thing is integrand, in the integrand I have cos x, I have sin x, but I don't have anywhere tan x by 2. I don't have anywhere tan x by 2. So you all might be thinking that how could tan x by 2 the substitution? Okay, so there is a point in this, and what is it? You don't see tan x by 2 in the integral, but you see cos x and sin x in the integral. If you remember, we had done a formula where we wrote cos x and sin x in terms of tan x by 2. So let me write here that formula. If you remember, we had written cos x and sin x in terms of tan x. So please let me write formula over here. If you remember, cos x is 1 minus tan square x by 2 upon 1 plus tan square x by 2. And sin x is 2 tan x by 2 upon 1 plus tan square x by 2. 2 tan x by 2 upon 1 plus tan square x by 2. So when I put tan x by 2 as t, looking at this integral, try to understand. When I'm putting tan x by 2 as t, looking at this integral, the reason being this cos x, I look at this cos x as this. This cos x, I see this cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. And this sin x, I look at it as this. So in cos x, I see tan x by 2. In sin x also I see tan x by 2. That is the reason I put tan x by 2 as t. Okay. I hope much of the things I have made clear. Now, whatever little is left, don't worry, students. You saw even in the first type, when we solved problems, we understood that the problems are very simple. Okay, the same thing is going to happen here. Just do not worry. So put tan x by 2 as t. If tan x by 2 is t, then see x by 2 will be tan inverse of t. X by 2 will be tan inverse of t here. It will be tan inverse of t, and then x will be 2 tan inverse t. 2 tan inverse t. I will differentiate with respect to t. I will differentiate with respect to t. So I get here d by dt of x, and here I get, since I am differentiating with respect to t, 2 is a constant, d by dt of tan inverse t is 1 upon 1 plus t square. Now this dt will multiply up here in the numerator, and that will get me, therefore, dx equals to 2 dt upon 1 plus t square. You can check. So here I got dx is equal to 2 dt upon 1 plus t square. Okay. So I will get, therefore, this is my step 1. Now check what is step 2. Step 2 here is, this is step 1. Now I write step 2. Step 2 is write cos x as 1 minus t square upon 1 plus t square. You know why this? You know why this? Because cos x is 1 minus tan square x by 2 upon 1 plus tan square x by 2. And you know, students, tan x by 2 you took it as t, so this becomes 1 minus t square upon 1 plus t square, 1 minus t square upon 1 plus t square, and sin x is 2 tan x by 2 divided by 1 plus tan square x by 2. So this will become 2t upon 1 plus t square, 2t upon 1 plus t square. Sin x is 2t upon 1 plus t square. Then step 3. Step 3 is write the integral after you will have done all this, that is dx in the given question, that 1 dx, that is dx you will have written as 2 dt upon 1 plus t square, and wherever you have cos x and sin x you will have put as this. Then you will notice that the given integral is converted into the type 1 upon quadratic, or it would be in a form where you can apply the theory 1 result, set 1 3 theories. Okay, so write the integral in the form 1 upon quadratic. See, it will change in this form, 1 upon quadratic dx, that is 1 upon ax square plus bx plus c. Okay, 1 upon quadratic, rather I should write dt, 1 upon quadratic dt, because everything will have changed into this, that is 1 upon at square plus bt plus c, at square plus bt plus c dt. Okay, and you know, students, once you end up getting this form, you know the method, how to integrate. So what will be step 4? Step 4 is integrate this, because this you have already integrated. That will be step 4. So we will not write step 4 because it is now understood. Once we end up getting this form, we will start integrating. Okay, so you can say in short that if we have this type, so integrate this type, what we do, we convert it into this type. We convert that type into this type, and once we get this type, we already know the integration of this type. So this is what the steps are. I hope you followed the steps. You can once again see it. I'm going to solve a problem now. Let's solve a problem. This is exercise 3.2b, exercise 3.2b, and it is second, fourth. Writing these all hardly matters, you know. You could be from any board or any textbook you are referring to. So what is important for you? The type is important and the method is important. Okay, so this problem which I'm writing, which is fourth here, it could be 14th in some other textbook, so that hardly matters. What is important? How do we solve the problem? That is important, and that you all have understood. So here we have, students, 1 over 3 plus 2 sine x minus cos x dx. Okay, so I go ahead and I integrate this. So first thing, what type is this? Do I know the type? Yes, it is this type. You know, students, what happens many a times, a problem could not be solved by a student because she did not realize what type it was. So I remember the type, I know the solution. How do I solve? So here I go ahead and I write here, put tan x by 2 equals to t. Put tan x by 2 equals to t. So when tan x by 2 is t, what is x by 2? X by 2 is tan inverse of t. So x is 2 tan inverse of t. Then I differentiate with respect to t, and I get d by dt of x equals to d by dt of 2 times tan inverse t. This gets me here dx by dt equals to, 2 is a constant, derivative of tan inverse t with respect to t is 1 over 1 plus t square. So I have dx is equal to 2 dt over 1 plus t square. And what more? So here, having got this, now what I understand is 1 dx, which is dx. Look at the numerator in the given integral. 1 dx you have, which is dx. For this 1 dx, what are we going to write? We will write 2 dt upon 1 plus t square. So mind it, the new integral that you will write, it will now in the numerator, it will have 2 dt upon 1 plus t square. The new integral you will write, it will have 2 dt upon 1 plus t square in the numerator. Why? Because for 1 dx, you are going to write this. So if you have dt as the differential in the integral, can we have x here? Can we have something in x? The answer is no, no, no. Why? You have a function of x when you have dx. See, you had dx, so you had everything in x. Now, since you are going to write the things in dt, since you are going to have the differential in dt, so everything has to be in terms of t. So, you know, this sin x has to be written in terms of t, and cos x also has to be written in terms of t. You already know the method. How do we write sin x and cos x in terms of t? And what was that? I had already shared with you the formula. Okay, so the next step here we write, students, is this. I write, we know that you will write cos x in terms of tan x by 2. The formula is, what is cos x equals to? It is 1 minus tan square x by 2 over 1 plus tan square x by 2. So cos x, I get 1 minus t square upon 1 plus t square. Then sin x we have here, sin x is 2 tan x by 2 upon 1 plus tan square x by 2. This is 2. you have 2t upon 1 plus t square. 2t upon 1 plus t square. So now the next we will write is, see, having done all this, the next step would be to write the integral totally in terms of t. So the new integral which I will write, it will be in terms of t. So for 1 dx, what are we going to write? We are going to write 2 dt upon 1 plus t square. It is 2 dt upon 1 plus t square. Then we have in the denominator 3 plus 2 sin x. So I will write 3 plus 2, and sin x is 2t upon 1 plus t square minus cos x. So we write minus, and cos x is 1 minus t square upon 1 plus t square. So we have therefore I equals to 2 dt upon 1 plus t square. 2 dt upon 1 plus t square. Here I take the LCM. The LCM here is 1 plus t square. So what would I get in the numerator? Here I have one term as 3. I have one term as 3, and the another term here I have this, and the third term is this. Okay. So accordingly, since the LCM is here 1 plus t square, I will get here 3 times 1 plus t square, plus here I'll get 2 into 2t, that is 4t. I'll get 4t minus, here I get 1 minus t square. 4t minus 1 minus t square. This and this 1 plus t square cancels. I get I equals to 2 dt, and multiply 3 inside, 3 plus 3t square plus 4t minus 1 plus t square. This will get me therefore I equals to 2 dt, and here 3t square plus t square is 4t square. 3t square plus t square is 4t square plus 4t plus 4t. 3 minus 1 is plus 2. So I take 2 common from the denominator, and that 2 will cancel this 2. So I get 1 dt, and here I get 2t square plus 2t plus 1. 2t square plus 2t plus 1, and here you got 1 upon quadratic. 1 upon quadratic. So here onwards, what will happen? The another method will start. How do you integrate 1 upon quadratic? You remember the first step? The first step was we make the coefficient of t square 1. Okay, so I take 2 common, so here I get 1 upon 2. I will get t square plus t plus 1 by 2 dt. This 2 will go outside, 1 upon 2 will go outside in the next step. Yes, and then what is the next step? You find out the proper last term. What is the method to find the proper last term? The method is you take half the coefficient of t and square. Okay, half the coefficient of t. What is coefficient of t? 1. What is half of 1? 1 by 2. And what is square of this? 1 by 4. So the proper last term here is 1 by 4. So what I do is I add 1 by 4 and subtract 1 by 4. So t square plus t plus the proper last term 1 by 4 minus 1 by 4 plus 1 by 2 and dt. Now what happens is the first 3 term will get you the perfect square. So I have I equals to 1 over 2, 1 over 2, 1 upon t plus 1 by 2 the whole square, 1 upon t plus 1 by 2 the whole square, and here I have minus 1 by 4 plus 1 by 2, that is equal to plus 1 by 4 dt. Okay, please, most of the students commit mistake over here, you know, and that is so silly if you commit a mistake at this point. It is minus 1 by 4 plus 1 by 2, so please be careful what you are writing. Okay, the correct thing is plus 1 by 4. You can take your own time to calculate this. So plus 1 by 4. Next step, I write 1 by 2 outside, 1 upon, see this is t plus 1 by 2 the whole square, plus this is 1 by 4. I write 1 by 2 the whole square. And this is a theory from set 1. Okay, it is one of the theory from set 1, that is 1 upon variable square plus constant square. If you have 1 upon t square plus a square, you would write 1 upon a tan inverse of t by a plus c. I'm writing the integral in terms of t, and you know, if you have x, then everything in t will be replaced by x. So here I have, so 1 over 2 and 1 upon a. What is a? A is 1 by 2. Tan inverse of variable upon a. What's the variable? Variable is t plus 1 by 2 upon a. 1 by 2 plus c. Plus c. So next step we get is, we get the next step here as this 2 will cancel this 2. So I have I equals to tan inverse of, I take LCM in numerator and simplify this. So I get 2t plus 1 by 2, 2t plus 1 by 2. And here I have 1 by 2. So that denominator 2 will cancel. And I get I equals to tan inverse of 2t plus 1 plus c. And what was t? T was tan x by 2. So I get tan inverse of 2 tan x by 2 plus 1 plus c. This is final answer. You can watch this. You can watch this several times in order to have confidence over the solution. You should also write these problems. You should solve similar kind of problems. Whichever textbook you are referring to, you have number of such problems, whether I have said it or not, during solving the problems or during giving you the solution of a question. Whichever type of question I take, I might not be giving you some extra problems for practice. It is for the reason, whatever textbook, whatever reference book you are referring to, you have number of such problems for such types. So whatever textbook you are referring, you can find out the similar type of problem and solve this. I have taken this problem. I hope you have followed this. Thank you.